Alrighty. Hi, welcome. So I'm sure I've introduced myself by now, but if I haven't, I'm Brandon. I'll be teaching this course. Welcome to Intro to Data and the Data Analysis Process. Should be pretty exciting stuff. We're going to talk a little bit about kind of what data is, different kinds of data, and how we would think about that, how we would classify it, how you can store it, and how it's actually collected. Some of the big picture of what data analysis is versus data science, data engineering, things like that. And then we're going to look at a couple basic statistic tools. And so the rest of this course will kind of be going into more detail on all of this, and this will give you a bit of an orientation, and then we'll move forward and we'll use tools to do the things we talk about in this video. So this is a lot of big picture stuff. It's really important. I'll probably make you re-watch this at the end of the course, just to tie it all back in together again, or do a kind of more synopsis kind of thing. But these ideas that I'm presenting today are going to be woven through the entire data course. And anytime you're working with data, these are things to be keeping in mind. So up first, what is data, right? So information versus data, you might be asking, well, what really is the difference between those two things? And so information is derived knowledge, right? So like I have a bunch of books up here, or I can look at the art on the wall, whatever. And as I'm doing that, I'm taking in information. There's all of this information that exists out there, but it's not organized, right? It's not collected, it's not encoded, it's not organized really. It's just sort of out there, right? I can go outside and wander around my yard and look at trees and things, and there's all this information I can take in, but it's difficult to do things with that, especially from a technical perspective. And so we're going to talk about information is derived knowledge, things that you just get, knowledge that you get from wherever, right? But encoded information, we got to have some way of communicating about that. And so encoded information is data, right? We store it, we communicate it, right? And that's when it becomes data, is when we're actually going to start using it and organizing it. So next question, let's talk about data types. And so there's two main kinds of data. There's numeric and categorical. And so numeric is going to be in numbers, and it's going to be, like how far do I drop this egg before the egg breaks, right? You can measure that. It's quantifiable. Alternatively, there's categorical, right? And so that would be like, different colors of things, right? That sort of a deal. We'll get into a little bit more of this, right? So continuous data, actually these first two, continuous and discrete, are our numeric types, and then the bottom two, ordinal and nominal, are our categorical. We'll talk about that in a second. But this might be something you want to write down because it will come back into play later. So continuous data, this is numeric data. It's just going to be numbers. But continuous data is essentially data you can put on a number line. It's linear and infinite, right? So temperature is an example. You can measure about the temperature outside, but there's always going to be a precision to it. And that can be really hard to measure, right? So like we say, oh, it's 34 degrees outside. It's not. It's a little warmer than that today. But you say, oh, it's 34 degrees outside, but really it's like 34.7281. You know what I mean? Like I can get really precise with that. And so that's what we mean by continuous data, right? Is that there are no jumps or skips between things. You can get as nitpicky as you want to with how detailed that can get, right? So that's continuous data. And again, the more precise you get with it, it can be infinitely precise as you get into those details. Alternatively, we have discrete, and again, this is numeric, this is numbers, right? But these data types really only have whole numbers, right? Like how many apples did I have for lunch? 5. That also is a lie. But you can this is a whole entire thing, right? How many vehicles do I own? How many children are in a household, right? The average is 2.5 or whatever, but you can't have half a child, right? So you either have 2 children or 3 children, but you can't have 2.5 children in your house. And so also just please note that it's very different than the word discrete, which means secret. They're spelled differently, and for your to avoid your embarrassment, please make sure that you know the difference between the two so that you don't spell it wrong sometime and then feel a little silly when we're talking about secret numbers and secret data, because that's not a thing. We're talking about discrete, which means specific, unique, discrete numbers. They're whole numbers here. All right. So those are the numeric ones, either continuous or discrete. And then we have categorical. And so our categorical data is going to be a little bit different. Ordinal data is a set of ordered categories, right? Like they come in a logical order. So like shirt size, for example, is ordinal data. We've got small, medium, large, et cetera, et cetera. Alternatively, nominal data, it's similar to ordinal data, but it's not ordered, right? Wow, shocker, okay? So this could be like geographical, right? Like Norway doesn't come before Colombia, right? Like they're just different places, right? There's not one that comes naturally before the other one. They're just different. So it could be geographical. It could be options between getting the news in print, online, or via television, especially if you're like using survey data. Sometimes you'll end up with these categories that you're going to have to figure out what to do with that data. This also includes binary data, political affiliations, right? Are you, Democrat, Republican, or none? And more. Like there's all these different like the categories of things that we could use. So numeric and categorical are kind of the two big ones, and there's kind of two parts to each of those. So up next we've got collection and structures. There's two main ways that we collect data, or I guess kind of categories of ways that we collect data. Obviously there's a lot of ways that we collect actual data, but there's kind of two categories for how we do it. And so we've got observational versus experimental. We'll get to that in a second. We'll also either have structured or unstructured data. So let's look at our collection of data. So we've got either observational or experimental. Observational data is collected by a person or device that passively takes note of something. Okay, what exactly does that mean? Well, so this would be, taking surveys, things like that. Most data is going to be observationally collected. So for example, how many visits were on a website, how many sales were on a given date, the number of emails you get in a day. Sometimes it's purposeful data collection, sometimes it's not. So for example, or it's also sometimes called found data, right? Like it's not, we'll talk about the alternative in a second. But it's sometimes just collected because it's free, right? And easy to collect, even if you don't use it for much, right? So like Facebook collects a ton of data. Like who likes what exactly, right? They don't necessarily use all of that stuff, but it's free data that people just give them, and so they collect it and they hold on to it. Sometimes it's political polls and it's collected on purpose, kind of a whole variety. You might be thinking, well, what other kind of data collection is there, right? Like it kind of seems like it's really summative. Well, that is true, but there's also a much more precise, specific kind of data collection called experimental data collection. And what I want you to think of is the mad scientist in his mad scientist costume, right? In his well, not lair, I guess, but like a scientist or something like that. Forget the mad scientist part too. Just a scientist in general, right? And they've got lots of control over what's happening, and they really want to see what happens if I change this one variable. Everything else is controlled. Everything's very taken care of. It's very precise, right? And I'm going to change just one thing and see what happens, right? And that's an experimental data. And so this is kind of the gold standard of data for researchers, especially. So things like clinical drug trials, right? Like we're going to say, try and keep everything the same for these two groups of people except the drug that we give them, right? And this will include like a variable. It will include control groups. This is also often called A/B testing. And so that's where I really want you to think about for experimental data, right? Like this is not like, I went outside today and I saw that it was nice weather. So I wrote in my journal, we have nice weather, just like I've done for the last 50 days, right? So that would be, observational. I went outside and observed it. Alternatively, if you were to generate weather specifically in an area and change one thing about it, like we've given it more humidity, what happens now, right? That would be experimental and also impossible. But you get the idea. So, okay, moving on. Structure. How do we structure our data? Whoa, I went in the wrong direction. Whee! Hope you don't get nauseous. Will not be the last time this happens. All right, structure. So structured data, like how do we organize our data? How do we look at it? Okay, and so structured data is going to be like a table or a spreadsheet. It has a sense of order. Really, really useful to have this. It's very easy for data analysts like ourselves. Call yourself a data analyst. You're here, so this is what you're going to be. So for data analysts like us, it's much easier to work with a table or a spreadsheet. There's lots of software, lots of programming languages, very easy to do analysis on it. And it has a sense of order, right? Like it's organized. So cool. Alternatively, we have unstructured data. So this is going to be things like tweets, YouTube videos, songs, Pinterest boards, right? That's data, it's information, it's out there, it's encoded, it's to some degree organized, but as it says here, unstructured data requires careful planning to work with. You really got to think about, what am I going to do to get this data to be useful, right? So like, let's say you're saying, I'm going to go through all of so-and-so famous person's tweets to see how much they talk about this particular topic, right? You gotta find a way to work through that stuff. It's not like they're like, here, it's in a nice spreadsheet for you. Here's how many tweets I have where I talked about this. You gotta go out and figure out that kind of thing. And it gets more complicated because imagine that they talk about the thing without using the word for the thing, right? Like, there's a lot of things that talk about, say, I'm not gonna do that. Anyways, but like, you can have things to get around it, right? You get the idea. Without directly saying that thing, but we're still talking about it. How do you know? How do you pick up on that? And that's part of why it requires careful planning, right? Is it's not as though somebody goes through and says, well, in this tweet I talked about this topic, this topic, this topic, and this topic, right? No, that's not how communication works that way. So YouTube videos, the same way, right? Songs. How many songs are in the key of E flat major? You got to do some homework for that one. So, cool beans. So that's collection and structure. Next, the data process. Cool beans. Where do we fit into things? Well, so there's kind of these 5 different phases of data and how it works. And some of it is very much not applicable to what we will be doing here. So if you came here to learn machine learning, this is the beginning steps of that journey. But I will not touch that within this course of the 10-foot pole. That is not the goal of what we're doing here. And data engineering is also not really my goal. What we are looking for here is to be data analysts. We want to say, what does the data say and what does it mean? The collection part of things, that's going to be, how is the data brought in? How is that collected? The only reason that we're going to talk about that hardly at all is so that you understand a bit more of the background of the data. And it really helps you to know if it's good data, right? Because if you're a data analyst and your data engineer is doing a terrible job, you might have to say, hey, this is just not like, you think this is unbiased data that you're giving me, but it's really horribly biased, right? That kind of thing. You might need to be able to identify that. So anyways, the collection of it, there's going to be important ways of how you get that data in the first place. The data analyst's job, we're going to take that data, and it might not be organized just yet, right? In the same way that we have all these YouTube videos, and we can say, how many YouTube videos talk about this thing, right? And you're going to need to figure that out. Well, some of that's going to be cleaning. Sometimes the videos are going to be in formats you're not used to. If you take like a survey, sometimes people just won't answer certain questions, and you're going to be like, well, great, now what do I do with that, right? I can say, well, they all said yes to this political idea. But that's not true. They didn't say anything. So now you have to make a decision what you're going to do with that, right? So that's the cleaning side of things, making sure that the data is actually as organized as you need it to be to make decisions about it. And then we've got exploratory data analysis. And this is going to be probably 90 to 95% of what we focus on in this course, because that's most of a data analyst's job. And so we're going to be looking at getting in deep with the data, getting familiar with it. I used the word intimate with data, and somebody chewed me out for that one. But so it's using familiarity with your data. You want to know it well, right? You want to know it through and through, and say with confidence, this is what the data says. But that requires some time. It requires some soaking in the data. And so you're going to be exploring it, right? We're going to be like data detectives. That's kind of the idea of what we're going to be working through here. So that's going to be exploratory data analysis. After that, especially with machine learning, there's kind of the so what part. Not all companies have machine learning. So again, that's not going to be something that we're going to focus on hardly at all here. But in the machine learning process, at that point, they would take that and say, well, we want to make code that predicts what's coming next as well as possible. And that's going to be the model building, and then finally model deployment where they actually use the thing. But the other thing that data analysts end up doing is saying, well, so I've done the exploratory data analysis. This is what it says, and then you're going to go present to somebody, because more and more often businesses are moving towards a data structure, data-driven business, and they're going to say, hey, we want you to look at the data and tell us what it means, right? So we want to do a marketing campaign next month, but we don't know where our top sales areas are, and we want to know which customers we should do marketing towards and what we should tell them about to try and get more people to buy our stuff. And your job is going to be, go look at the data, figure that stuff out, and then go tell the business people, hey, this is the conclusion I had from this data. I know all the data really well. I've looked at it. Here's some charts and some graphs, so it looks colorful and pretty to you non-data people, because if you just tell non-data people data words, you will not be very useful at your job. So you got to show it in normal people talk, what's going on and how that works. And so that's going to be a big part of the data and analyst's job as well. And data scientists kind of do the whole thing. Their job gets pretty wild from day to day, but it's pretty cool. Anyways, oh look, I made it bigger. Woo! All right. Cool. So a couple basic statistics tools. Really, really basic. We'll go back over these later, but I wanted to get into these before we moved into some of our programming languages. So basic, simple tools. So first of all, the mean is the sum of all the numbers divided by the count of the numbers, right? So you take your whole data set and you say, I've got a data set of 7 million items, and so I'm going to add them all together and then divide by 7 million. And whatever that number that I get back is the average. That's the mean. That's like the most middlest thing in that way. And so part of what we're trying to figure out with these tools is tell me about the data, right? Like if I don't know anything about this, what am I going to choose, right? So we're going to say how many birds are in the average American yard, right? So we're going to take all of those birds, that massive bird count, and then divide it by the number of yards, and that will tell us the average number of birds in someone's yard. The median is the midpoint of the data range if you sorted it in order. So we start out with yards that have 0 birds, and then we have yards that have hundreds of birds. Okay, we're going to organize them all, and then we're going to say whatever is at 50%, right? So again, we've got 7 million. So the 3.5 millionth value, whatever that is, okay, that's our median. And so this is, you might be, well, what's really the major difference? Wouldn't that kind of be about the same? And it's not usually the same. That usually tells us something, right? Because if the mean and the median are very different, that tells us that a lot of our data is skewed over to one side, it's scrunched over there. And so that's going to be what the median tells us. And then the mode is the most common value in the data set, right? So let's say that our mean is 5 birds per yard, and our median is 4 birds per yard, but the mode is 2 birds per yard. And that means that like most yards have 2 birds. That's the most common value. Okay? And then standard of deviation, for the time being, we'll say this is how scrunched together our data looks, right? So you might have, no values, and then at 5 birds per yard, it's like, boom, and like the vast majority of them, and you will see data sets that are like this. It's like one big spike in the middle, and then it go back down to nothing. Or it could be a really gradual kind of bell curve kind of a deal, and that will tell us something very important as well. So those are kind of our simple tools here, and we'll keep moving, using these, moving through with these. We'll see these in our programming languages coming up here, and it should be pretty cool for how we're going to do this stuff. So good tools to think about, good tools to use. Will tell you an awful lot about your data. So another thing you should know about this course, I try and keep my videos to about 20 minutes or less. So we finished this video, go get a drink of water, because hydration is good for you. So I'll go drink some water, you go drink some water, and then we'll come back to the next video. Should be rad. Looking forward to working with everyone, and I hope you're excited. See you in the next video.